This is Airflow by Alexander, Zizix, and Adrian. I'm going to be introducing the intake system and manifold. The intake system delivers air into the engine and distributes the air equally from the intake filter through the intake pipe and then the throttle body to the plenum and then through the runners. Some manifolds have injectors that spray fuel through the manifold into the intake valves when delivering air to the combustion chamber. Dual-plane manifolds are better for low to mid RPM range. Single-plane manifolds are better for higher RPM ranges. The size of the throttle body matters because a bigger throttle body allows for more air to be introduced into the engine. The throttle body plate opens and lets in more air depending on the position of the accelerator. Carburetors were used before modern intake systems. Carburetors allowed air to enter a narrowed section inside the carburetor. Then air speeds up and pressure drops. This drop in pressure draws fuel through small openings called jets into the airstream. Carburetors were used on single or dual plane manifolds. Right here we have a picture of the throttle body or throttle plate, the carburetor, and right here you can see the intake manifold runners. Here is a single plane manifold, a dual plane manifold, and a better angle of the inside. And then here is a modern manifold. You can see the plenum, runners, and throttle body. Some more ways to get power and performance would be through the intake piping and the air filter. A restrictive air filter forces the engine to work harder for the necessary amount of air. Colder air is more dense, which leads to more oxygen and a gain in horsepower. Another important part of the system would be the MAF sensor. It's important for sensing the amount of air entering the intake, which also calculates the amount of fuel needed for the air-fuel mixture. We have the intake tubing with the filter right here and a picture of the MAF sensor right here. That's all I have for the intake system.
Exhaust manifolds. The exhaust system is designed to allow exhaust gases to flow out of the engine efficiently, which helps the engine breathe better. A smooth airflow prevents back pressure from restricting the engine's operation, leading to improved power and performance. It is desirable to have as much of the exhaust gas as possible out of the cylinder before the piston begins moving upward in the cylinder. This will reduce the pumping loss associated with compressing exhaust gas as the piston approaches top dead center. Exhaust headers. Exhaust headers improve engine performance by providing a less restrictive path for exhaust gases to exit the cylinders, which reduces back pressure and increases engine efficiency and power. Increased efficiency. By optimizing the exit of exhaust gases and improving cylinder filling, headers help the engine operate more efficiently. This produces higher horsepower and torque, especially at higher RPMs. Types of exhaust systems. Single exhaust with two exits, true dual exhaust. Exhaust restrictions will cause a noticeable loss of power. Restrictions result from collapsed pipes and restricted flow through mufflers and catalytic converters.
The big air pump. A motor is basically a giant air pump, and its main job is to get air in and out of itself to create power. Modifying the big air pump by increasing the volumetric efficiency to make more power. VE basically means perfect breathing conditions, but in a more professional term, maximum amount of air that is being displaced based on the bore and stroke of your engine. One way of increasing VE is by porting and polishing. Porting and polishing are primarily done to improve high RPM performance. Porting is when the passageway of the ports is altered by making it bigger and more open. Polishing smooths out the surfaces of the ports. If you take a look here at the images on the bottom, these are possible locations. You can alter the port by making it bigger and smoother to help increase airflow. Port matching lines up the ports in the intake manifold with the ports in the cylinder head to increase port flow to eliminate turbulence. Using gaskets as templates to make a layout of the port shapes for the intake ports and then the exhaust ports. Use a milling bit for the porting, then use a polishing bit to smooth out the surface finish. Another way of increasing VE is by modifying the cylinder head with oversized intake and exhaust valves. That means you will have to cut the seats bigger on your cylinder head to fit the diameter of the oversized valves to allow more flow in your ports. When doing this, make sure the valve is not shrouded by the chamber because the valve is too oversized. Shrouding can restrict the flow around the valves. If shrouded, grind the chamber only if it will not affect the sealing surface of the head gasket. Keep in mind, grinding the chamber can and will reduce compression. Try not to get too big of oversized valves because it can lead to these issues. Exhaust valves can have a small radius polished onto the head to reduce turbulence and gas flow around the valve port, as seen down here in the bottom right corner. Once you are done porting and polishing your heads, you can go ahead and take them over to the flow bench, and then you can begin to measure the airflow, which is being measured in CFM, also known as cubic feet per minute. Then you will see how much airflow has increased, and you will see the difference between before and after porting and polishing, and how much it can help with your performance and airflow.